There is no more eloquent way to see how poor the conventional understanding of light is than by performing experiments with prisms. Newton performed a number of them more than 300 years ago. The setup for a basic experiment like that couldn't be simpler. A narrow beam of light is passed through a triangular prism, with the exiting light being projected onto a screen. The result is an image of an array of rainbow-like colors, which Newton named the spectrum. Now, since this video is mainly intended for those in the know, I will not embark here on some popular presentation of all the details involved in an analysis of the experiment. Neither will I repeat them for those who know them, for that would be completely unnecessary for the issue at stake. The only thing I will do is to show an image of a resultant spectrum. Here it is. You all know about this distribution of the spectral colors, and you also know the Newtonian interpretation about what causes this particular distribution. Have you ever cared to analyze, however, the other spectral distribution? The one displayed to the naked eye, or to the eye of a camera, when a beam of light is observed by looking at it directly through the prism. I call that the Aristotelian distribution. Here is an image of that kind of spectral distribution. Take a close look at each individual source of light in this image. Observe the distribution of the spectral colors in every case, keeping in mind that the only difference between the setup for the basic Newtonian experiment and this one is that in this case the image of every source is not captured by a screen but by the eye of the camera. Okay, here comes now challenge number one for the conventional physicist. Can you explain, by using the current theoretical understanding of course, this distribution of the spectral colors? I encourage you to get yourself a prism and look through it at any source of light you can think of. It will help you so much more to understand why I believe that this is a valid challenge to the conventional understanding of the nature of light. Good luck! Let's get back now to a basic Newtonian setup. There it is. The image on the screen is just a bit different now, but that does not change in any way the things we are dealing with, does it? I'm sure there's no need for additional explanations. Okay then. Now please pay attention to what I'm about to do. Here's a close-up of what happens on the screen. The picture quality is poor, I admit, because I'm only using an ordinary webcam to film all this. That's in order to keep the promise I made in my first video that I'll use experiments costing no more than a modest dinner, remember? If you perform all these experiments for yourself, however, you will enjoy a crystal clear picture, as you know. Okay, here comes challenge number 2. Using the conventional theory, can you explain the results of this experiment? Good luck. Back with the basic Newtonian setup. This is my last challenge for you. Please pay attention to what I'm doing now. It's even harder than before to see what I want to show you, but I'm sure you get the picture. No pun intended. a close-up will make it easier, so here it is. Now here is challenge number 3. Can you explain these results with the help of the conventional theoretical understanding? Good luck once again. This concludes my challenges for you on this topic. I promised in my previous video, however, that I will give you a clue about something you don't know, something essential to our bone of contention. Here is that clue then, in silence. All is left for me now is to wait patiently and hungrily for your move. Bye for now.